Module 4, question number 13. To test H naught, or the null hypothesis that the mean is equal to 20 versus H1, or the alternative hypothesis that the mean is less than 20, a simple random sample of size n equals 16 is obtained from a population that is known to be normally distributed. Answer parts A through D. Part A, if x bar equals 18.2 and s equals 4.2, compute the test statistic. Now, you can do this. You can use the formula. I'm going to walk through in StatCrunch. Again, I recommended this a couple times. You can do it by hand the first few times. Once you know how to do it, I recommend doing it in StatCrunch just to alleviate or to avoid some of that error. So let's go to here. I just opened StatCrunch. Let's go to Stat. T-stats. Remember, we're dealing with the population mean, so it's the T statistic. With summary, we don't have a data set. We just have the summary data. Here, we're given the sample mean as 18.2. We're given the sample standard deviation as 4.2, and the sample size is n equals 16. Here, we're also given the null hypothesis is mean equal to 20. Now, I posted something about this too. Make sure you remember, if you're saying that the character is mu, mu, but the word is mean, the standard, the population mean. And then the alternative hypothesis is less than 20. So here we have our test statistic, and here it says to round it to 2 decimal places. That makes negative 1.71. Okay. Part B, draw a t-distribution with the area that represents the p-value shaded. Which of the following graphs shows the correct shaded region? Now, just to remind you guys, going to our lesson from this week, this is also from the text and the lesson I posted for Module 4. If our alternative hypothesis is that the population mean is less than some number, it's a left-tailed test. In a left-tailed test, you can see here from the diagrams, the p-value is that area shaded to the left of some test statistic. So that's saying, what's the probability that that t naught is less than this value right here? So here, let's look at that. Obviously, that then is there. So when we have a left-tailed test, we're looking at that area shaded to the left. Part C, approximate the p-value. Choose the correct range for the p-value below. Now, just to show you, we already calculated it over here. It's 0.053. So let's see if we can find that. That would put us in this range. Now, just to kind of go back, if you were to approximate that without finding it in StatCrunch, what's one of the ways that we could have figured that out? Well, we know that it's going to be on the lower end. It's not going to be up here on a high end where you're doubling your probability, or it's not a big probability. You know it's going to be in that lower range. And it's confirmed then when you calculate it. It never hurts to calculate just to double check your intuition or whatever you hand calculated. If the researcher decides to test this hypothesis at the alpha equals 0.05 level of significance, will the researcher reject the null hypothesis? Now, remember, if the p-value is less than alpha, then we reject the null hypothesis. However, this p-value is actually more than alpha. So we would not reject the null hypothesis since the p-value is not less than alpha. Let's double check that. The researcher will not reject the null hypothesis since the p-value is not less than alpha. I highly recommend with those when you're trying to translate what you would do with your conclusion from the hypothesis, reread them because sometimes they can be a little confusing. But I hope that answers any of your questions about number 13. If you have any questions about this or any other ones, let me know.